Hey, welcome to 8.4 part, is it 8.4? Yes, 8.4 day 2. Alright, welcome. To start off with, we are going to review what we learned in 8.4 day 1. So actually, if you even have that note sheet out, it would be really handy for you to just grab it. I just want to go run through what you learned yesterday. So I'm going to do it fast, look back if needed. First, common log. Remember, if it just says log, really, it's base 10. So feel free to add in the base 10. Natural log. If it looks like ln, really it's log base e, or you could say ln base e. Either one is fine. So fill that in if needed. Next, property. If I have anything, any base, and I have a 1 right here, the answer is 0. Next property I want to review. Let's say I had this, log base 6 of 6. Whenever these two numbers are the same, the answer is 1. Next property, let's say I had 4 to the log base 4 of 6 power. Remember I said that these cancel each other, so that answer is just 6. And we're going to talk more about that one today, which is going to be nice. Here's another one. I had log base 5 of 5 to the 2x, for example. If these are the same, then that whole thing cancels and just the exponent is the answer. And just a quick review. When I'm doing logs, let's say I said evaluate, set it equal to x, change it to exponential form, and then you do some guess and check action to figure out what the answer is. And I hope that we'll have time to work on that a lot, because that takes a while to get the hang of. To start off with today, for our new material, we're actually going to first review how to find inverses from Chapter 7. So we did this in Chapter 7. Let's just review and see if you remember. So from Chapter 7, if I'm going to find an inverse, remember, step 1, switch x and y. Step 2, solve for y. That's what we did in brief, as a brief explanation. So here I go. Step 1, switch x and y. Step 2, solve for y. X plus 3 equals 3y, divide by 3, divide by 3. Just don't forget to put the divide by 3 to both parts. So I end up with, either you could say x plus 3 over 3 like that, or I could split it up into x plus 3 and 3 over 3, which is 1. Why don't you pause it and try B and C and see what you remember from Chapter 7. Alright, you have unpaused. Here's our answers. And at this point, that part was review, so if you didn't remember how to do any of those, write that down, but you can ask me questions on that tomorrow. So we're not going to use the fifth written stuff in our today's lesson, because we're going to be using logs and e's. Just the main process of switching and solving is what I'm looking for. Okay, to find the inverse of a logarithmic function, the first thing you should know is that the inverse will be exponential. So the thing that we're going to talk about for the rest of this chapter is that logs and exponents undo each other. It's kind of like how if I had x squared, a square root undoes the squaring. If I have something logged of something, if I do an exponent, it undoes the log. And I'm going to say more about that in a little bit, but logs and exponents undo each other. They're inverses. And we actually solved this the same way we solved those warm-up problems we just tried, which is switch x and y, then solve for y. It usually takes students several of these to get the hang of it, but if you feel like you got it, go ahead and fast forward and then check your answers. I'm going to first switch x and y for part A, so I got x equals log base 3 of y, and now I'm trying to get y by itself. So here's why I wanted us to talk about those properties today. Basically, I need to get this to cancel. So here's what I want you to imagine. The way that I got a log base 3 to cancel in property format was, remember this property? If this base and this base are the same, those cancel each other and it's just equal to y. That's what I'm going to use. So this seems really strange, but whatever I do to an equation, I want to do it to both sides. Like if I multiply by 5, I multiply by both sides. If I divide, I do it by both sides. You maybe never knew this before, but I can actually also take both sides as exponents of a number. So right now, I took both sides as exponents of 3. And if you don't quite understand what I just did, let me rewrite it again. What I just did is I took what I had on both sides of the equal sign and I made them both as powers of the base 3. And the reason I chose 3 is because that's my base right here. That's the thing I'm trying to get rid of. The way this works is, see, check it out. Now I've got a 3 and a 3, so that cancels, and I have essentially just solved for y. And once you get y by itself, you're done. That's our goal. So I just found the inverse. And here's what I mean. The inverse of a log will be something exponential because they're inverses of each other. It takes a few to get the hang of it, so let's do the next one. Step 1, switch x and y. Step 2, solve for y. Now, I want to say something about this plus 1. Because at plus 1, usually you'd think, oh, maybe you're thinking in your head, subtract 1, subtract 1. We can't do that yet because that 1 is locked inside that parentheses. Because of the parentheses, we can't get rid of the 1 yet. We got to get rid of the parentheses first. Now, remember how I said a ln is really a base e? The reason I need to know what base it is because if I'm going to try to cancel this out, I'm going to make both of these that base. So essentially what I've done this time is what I had, I made as exponents of a base of e. See that? What I had previously I made as exponents of base e. Now my little shortcut is for me not to rewrite it, to just go like this, e, and then you'll know you're making them both exponents because e is now, I wrote it so it looks like the base. That's kind of a shortcut, but if that doesn't really make sense for you, it's totally fine to write it all out like this. And now the reason I did that again is because of that property we learned, that whole part cancels. So that's equal to y plus 1. That's still e to the x. So yay, I got rid of the parentheses. Now I'm at the stage where I can get rid of the plus 1. So I would subtract from both sides. So what I end up with is e to the x subtract 1 equals y. Alright, I'm going to now go slightly faster, and if you understood those, you could skip ahead to part E because C and D are just repeats. Alright, so here I go, a little bit faster. Step 1, switch x and y. Step 2, I'm trying to get rid of my log. This time I have a base of 2/5. I'm going to take both sides as exponents of 2/5. So my final answer is 2/5 to the x power equals y for part C. For part D, step 1, switch x and y. Step 2, I'm trying to solve for y. So get rid of the ln first, and to cancel out a ln, remember it's really ln of base e. I'm going to take both sides as exponents of e. So those cancel, it's just left with y to the 10th power. I have to get rid of the 10, so I add it. E to the x plus 10 equals y. Hopefully if you got that, you fast forwarded, but follow along now again because it's going to get trickier with E. I put in a bunch more stuff here and we're still going to switch x and y as my first step. The problem is I have to figure out what order to do everything in. So here's what I got to tell you. You want to work with the part that's multiplied with your variable last. So ideally I want to get rid of this plus 4 first if I can. And when I say if I can, this time I can because it's not locked inside of a parentheses. So if it's locked inside a parentheses, that's when you can't get rid of it first. Now I have this, and notice the 2 is still outside. The 2 is not with the log yet. It's not in a parentheses or anything, so I can get rid of that as well by dividing. And so now I have x minus 4 divided by 2, and it's your choice if you want to keep it as this or if you want to split it into 2 fractions. Either way is fine. Now I'm to the stage where I just have log base 3 of y. So now I'm going to take both sides as exponents of 3, and it looks weird, but there's my final answer. And if you split up the fraction, that would look like this. Either one would be accepted for full credit. F is actually a little easier. only this time I'm going the other way. So this time I have an exponent, and I'm going to try to make a log to get rid of the exponent. And actually I haven't taught you this yet, so make sure you're tuning into F if you haven't fast forwarded already. All right, here we are. I got x equals 2 to the y plus 1. Now I'm kind of going the other way. So we're going to use a log this time, because if you have a log, use an exponent. If you have an exponent, use a log. So you do the opposite of what you see. Now I'm going to first get rid of the minus 1. And I'm at the stage now where I'm trying to get rid of that 2 basically. I want it to just be a y. So and this time I'm going to use this property right here. And I use the numbers I'm using, but if you want, I'll rewrite it quick with the variables. So there we go. That's the property I'm going to use. So what that means is this time I want to take both sides. I want to take log base 2 of both sides. Let me show you what that means. So basically I took what I had. And I made it here and here, but then I put a log base 2 of both sides. And the reason I did that is this is that property where this part cancels, and that's just equal to y. So my final answer is log base 2 of x minus 1 equals y. Let's try part G. So similar problem. Before I take a log of both sides, I want to get the exponent by itself as much as possible, or the exponential statement. So this time, actually, you know what? Don't let me forget to switch them quick. So switch my x and y. Okay, there we go. Now I'm going to solve. So again, I want to get rid of this if I can, and I can this time because it's not locked inside. But now I want to point out I can't yet get rid of the 2 because it's part of the exponent. I can't just add 2 to both sides. That doesn't work. It's part of the exponent. So the only way to get rid of it is after the fact. What I'm going to do then is I'm going to take log base 4 of both sides, and the reason I chose 4 is because this is a 4. So now let me write this out clearly so you can see what's happening. So I'm taking log base 4 of both sides. And the reason I wanted to do that is because right here, that cancels. So I'm left with y minus 2 on that side. And another thing I want to point out is that this x plus 5 is, that whole thing got logged. So at the end, when I add 2, that doesn't add with the 5, because this is a plus 2 outside of a log, which is a very different number actually. So that's a plus 2 outside of the log. It's not with the 5, because the 5 is being logged right now. Alright, one more before we move on to our part 2 video. I've got y equals log base 5 of x minus 3. Step 1, switch your x and y. Step 2, solve for y. And this time what I notice is there's nothing else with here. There's nothing else I can add or subtract because this whole thing is in parentheses, so that's locked in there. So right away this time I'm at the step where, well, I see a log, so I'm going to exponentiate both sides. So I'm taking both sides as powers of 5. So if I want to write it out nice and neatly, this step is optional. That's what it would look like. But what's happening is those guys cancel each other. And so I've got 5 to the x power equals y minus 3. Add 3, add 3. 5 to the x power plus 3 equals y. On the next page, we're going to be graphing. Yay! Thanks for tuning in, and I'll talk to you again in a little bit. Welcome everybody. We're now going to talk about graphing logs. And by the way, my dog is right next to me drinking a bowl of water. So I don't know if you can hear that, but that's her drinking a bowl of water. Okay, but she's almost done, so I'll continue anyways. So here is our general format for graphing logs. We think of it like with this equation in mind. Y equals log base b in parentheses x minus h, and then outside plus k. And now this is cool because it follows along everything else that we've really done. So h is going to move it left or right, and k is going to move it up or down. In this situation, x equals h, and it's the opposite of what you see for h, is also a vertical asymptote. But the same rules apply as the other graphs we did. What I mean is, if it's a plus, it moves it left. If it's a minus, it moves it right. And for the k, if it's a plus, it moves it up. If it's a minus, it moves it down. I hope you're kind of getting to be experts at that knowledge right now. And I will show you more about this in a little bit. The domain of our log graph is always going to be x is greater than h. And the range is going to be all reals. And I want to just tell you that a log graph is an inverse of an exponential graph. So remember how an exponential graph had a domain all reals and a range x is greater than our asymptote. So this, or y is greater than the asymptote. So those two have just flip-flopped, and that's what happens when you do an inverse. All right, quick sketch. Depending on what the base is it depends on if it's an inverse of exponential growth or exponential decay. So if the base is greater than 1, it's going to look something like this. And right here would be the asymptote. If b is between 0 and 1, it goes this way instead. And the asymptote's still right next to it. And I'll say more as we graph. All right, here's what we're going to do for graphing. And I want to just tell you that actually graphing it, a lot of students struggle with this. So we're going to work together, and we'll do some more practice in class, because we're going to do 4 examples, but for a lot of you, 4 examples probably won't be enough. You might still feel confused at the end of this lesson, so we'll definitely work on this during class. But here's our steps. Write this down. Step 1, we're going to draw in our asymptote line. And remember, the asymptote line was x equals h, and it's the opposite of what you saw for h. So if I saw plus a number, it'd be a negative. So step 1, draw in an asymptote. Step 2, we're going to find 2 convenient points to plot. Find 2 convenient points to plot using your log knowledge. And I just want to throw it out there. Remember when we were doing the exponential graphs in 8.1 and 8.2, the 2 points that we found were 0, something, that was the y-intercept, and 1, something, that was some other point. We used those 2 because they were the 2 easiest points. This time we're going to have we're gonna also use that basically, only we're gonna have y as 0 and y as -1, and usually, and I'll say more about that in a little bit. But the recommended points that I would use are points such that I can make it so that I can use this property and that I can use this property. And that's not going to mean anything to you until I do the first example. But for now, just write this down. So I'm going to try to use the log base a of 1 equals 0 property and the log base a of a equals 1 property. Those are the 2 properties I'm going to try to use to find my 2 points. Step 3, we're going to plot our points and draw the sketch. According to what I just said earlier, where it could be b is greater than 1 or b is between 0 and 1, you just kind of have to draw it in depending on that. Alright, so let's do an example. So first of all, let's identify where the asymptote is. The asymptote is supposed to be the h value, but I don't see anything in there. This -1 is outside the parentheses, which means it's a k. If there was an h, it would be in the parentheses, such as it looks like for example b. That means there is no h value this time. And so really there is an h value, it's just 0. So I'm going to say there's, quote, no h, but really it's 0. Let me get myself set up here with my graph. That's just my xy coordinate plane drawn as best as I can. So I just said that x equals 0 is the asymptote. Notice that it's vertical this time. Asymptote x equals 0. And now here comes the hard part. So I'm going to attempt to find 2 points. My first goal is to use the property where I have log base a of 1, because I know that that whole thing is going to be equal to 0. So this is me trying to do this if, let's say, didn't have a calculator or something. But this is a method you need to do, especially if you're going on to trig next year or next semester. Alright, so here's what this means. How do I make it so that there's a 1 right there? Well, because that's just x, that means I could put in a 1 for x. And here's what that means then. I just told you I'm going to put a 1 in for x. Now the reason I did that is because my property says anytime there's a 1 right here, that log statement is equal to 0. So now I have 0 minus 1, that's negative 1. So 1 comma negative 1 is my first point. Here's my other goal. I'm going to try to use the property where both of these are the same. The base and this number are the same, because if that's happening, then that's equal to 1. So if I look at what I've got, in order to make this right here the same thing as that base, I need to make it a 1/3. So for this point, I'm going to have it be 1/3 comma something that I'm going to figure out right now. All I had to do was finish the formula. I want to point out that what I did is I took this and I replaced x with a 1/3 this time. That's all I've done so far. Now the reason I did that is because, again, if these two things are the same, that whole entire log statement is equal to a 1, and so my answer for that is 0. So 1/3 comma 0 is the second point. Now my graph is going to look like this time, and that's as specific as we're getting. So that's it for there. Because b is between 0 and 1, I had it be this shape. And then the other thing we'll do really quick is let's find the domain and range. Remember I told you, so this time the domain is x is greater than the asymptote. What I mean is all of my x's are over here. I don't have any x's over in the other region. So all of my x's are going to be greater than 0. So my domain is x is greater than 0. And remember I said this time the range is all reals. And the reason is if you look at the y values, all of the y values are going to be used if I made the world's largest graph. And I can say more about that when we get to class. Okay, so if you didn't quite understand that, keep listening, keep paying attention, because you will get it eventually, but usually this topic does take students several examples. So when I do 2 examples of a log graph, it might not actually even be enough. You might not get it until we do this in class tomorrow, but that's okay. Keep listening, because you will get it eventually. So remember I said step 1, find our asymptote and plot it. Actually, step 1, I'm going to draw on my xy coordinate plane. Okay, there is my xy coordinate plane. Step 1, find my asymptote then. So when I said the opposite of what I see, if I see a +2, that means my asymptote is at -2. And basically, this makes sense, because remember how I said that moves it left? Basically, I'm moving my asymptote, which would normally be at 0, I'm moving my asymptote left 2 units. So the asymptote is at x equals -2 this time. Now I'm going to find my 2 points. So first goal, I'm going to use this property. So what that means is I want to make this right here a 1. Now look at the formula we're given this time. You got to ask yourself, what do I plug in for x to make it so that this part right here is a 1? And so think back to the other problem. The other problem just had a plain x there, so all I had to do was plug in a 1. But now, in order to make this a 1, I need to plug in a -1 actually. So my first point, the x value is actually going to be -1. Alright, then in order to find the y value, I continue on, so I'm going to actually evaluate it, and the reason I chose -1 is this is now log base 5 of 1. Our property is anytime I have a 1 there, that whole thing is just equal to 0. And in this situation, there's nothing over here added or subtracted or whatever, so the answer is just 0 for the y value. -1 comma 0 is my first point for this graph. Here's our other goal this time. Well, actually, same as before, not this time. The other goal is to make it so that the base and this number are the same thing, because then I can have it equal to 1, so that again makes it easy. So let's take our formula this time. So again, I want to make it so that this part is the same number as 5, because that's what a is this time. So you got to ask yourself, what do I plug in to make this be a 5? And this time I plug in a 3. So the x value is 3. The reason I did that is that now I have log base 5 of 5, and whenever the number, the base and the number are the same, it's equal to 1. So 3 comma 1 is the second point. Now b is greater than 0 this time, or b is greater than 1 I mean, so the graph looks like this when I draw in my curve. Domain, x is greater than -2, and range, all reals. We're going to now move on to the natural log graphs, and this is actually, we're going to do it the same way, only it looks weird because of the e. So for part C, first goal, find my asymptote. You know what? I don't have a h value again. There's no parentheses. So my asymptote this time is again just at 0. So x equals 0 is my asymptote. There I go. Step 2, I'm going to use my two formulas. So the first one is to make this right here a 1. Right there, I want to make that a 1. So look at my thing I have. That's where the x was. What do I need to put in there to make it a 1? Well, because it's just by itself, I'm going to put a 1 in there. And remember, a ln log is the same as a log log. Same rules apply. So it might seem weird that I'm doing this, but same rules apply. So log base e of 1 is 0. That's why I wanted to do that. That means y is equal to 2. So my first point this time is 1 comma 2. To find my other point, I'm using this property. Log base a of a is equal to 1. Here's my formula, or my equation this time. So when I say log base a of a, I want this to be the same as this. Now the base happens to be e, so that means I want to put a e in here. Seems weird, but that's okay, because remember, e is really 2.72 approximately, or you know what, I'll just say 2.7. So if I put an e, really I'm saying x equals 2.7. That whole thing, because this and this are the same, that's equal to 1. And my y value this time is 3. So 2.7 comma 3 is my second point. There it is. Because it's a ln graph, the base was e, and e is 2.7. That is definitely greater than 1, so my shape looks like that. And I'm not going to do domain and range for these last two because I'm running out of time on this video. So I'm going to do as much as I can with part D, and if we run out of time, we'll finish it in class. So step 1, let's plot our asymptote. When I look at step 1, I see that it has a +2, so that means that my asymptote is moved left 2 units, so my asymptote is at -2. Now I'm going to find my 2 points. First goal is to try to make it so that this thing right here is a 1, because then that whole log will be equal to 0. So here's my formula this time. Alright, so I want this. I want to put something in there so that this parentheses is equal to 1. Well, to get it equal to 1, I need a -1. -1 plus 2 is 1. So x is -1 for my first point. Now to get y, anything, if I have a 1 there, that's equal to 0, so my y value is -1 for that first one. So -1, -1 is my first point.